The situation brewing in the Pacific Ocean might be setting the stage for a mega drought in the western United States that could last for decades, possibly locking the region into an extended dry spell unlike anything we've seen before. But here's where it gets controversial. New research implies this isn't just a natural cycle running its course, but a pattern possibly intensified and prolonged by human-driven climate change. For decades, scientists have understood that sea surface temperatures in the northern Pacific Ocean naturally swing between warmer and cooler phases every few decades. This phenomenon, known as the Pacific Decadal Oscillation, PDO, plays out over long time frames, with temperatures alternately rising above or dipping below average in key ocean regions. It's like a slow ocean heartbeat that affects regional climates, including precipitation patterns on land. However, since the late 1980s, the PDO has taken an unusually extended dive into its negative phase, where a distinctive horseshoe-shaped zone of cooler-than-average water surrounds a warmer core. Last month, this cooler phase set a new record for its intensity, raising alarms among scientists. While past climate simulations indicated that such a long-lasting negative phase could happen naturally, those models suggested it would be an extremely rare, maybe once-in-a-millennium event. Researcher Jeremy Clavens from the University of Colorado Boulder found that explanation unsatisfying. The climate models, if taken at face value, told us this was just bad luck. But that didn't seem to be the whole story, he explains. Why? Because teasing out human influence from natural fluctuations is notoriously difficult. The signal of human impact on the PDO is faint, often obscured by internal noise within the climate system, making it challenging for models to clearly pinpoint how much we're affecting these ocean patterns. To overcome this, Clavens and his colleagues conducted a massive analysis involving nearly 600 climate model simulations. This incredibly data-heavy approach allowed them to average out the random noise in individual models and identify the genuine impact of human greenhouse gas emissions on the PDO's long-term trends. Their findings were revealing. Up until about 1950, human emissions barely influenced the PDO cycle. But from mid-20th century onwards, roughly half of the changes in the PDO could be attributed to human activity. Interestingly, from 1950 to the 1980s, aerosol pollution, which tends to cool the atmosphere by reflecting sunlight, nudged the PDO toward its warmer, positive phase. Then, when air quality improvements reduced aerosols after 1980, combined with the steadily rising greenhouse gas concentrations, the PDO shifted and became locked into its cooler, negative phase. The research only covered up to 2014, but the negative PDO trend has stubbornly persisted over the last decade, even surviving El Niño events, naturally occurring warm phases of Pacific Ocean waters that usually would flip the PDO back to warm. Pedro D'Anezio, also from the University of Colorado, confirms this persistence in a related study. Our models suggest that as long as the northern hemisphere keeps warming, the PDO is likely to stay stuck in this negative phase for many more decades. Why is this a big deal? The PDO's negative phase tends to bring reduced winter rainfall to much of the western United States, compounding the already devastating effects of the region's ongoing megadrought, which began around the year 2000. We've long known that rising temperatures driven by human-caused climate change worsen drought conditions by increasing evaporation and drying soils. Now, a sustained cool phase PDO adds another layer, making the dry spell even harder to break. This challenges a commonly held belief that the PDO is mainly a result of natural internal variability within the climate system. As Tripti Bhattacharya from Syracuse University points out, this new research disrupts the prevailing view that the PDO pattern is just internal climate behavior. Moreover, Bhattacharya suggests this could mean climate models have been underestimating human influence on major ocean-atmosphere temperature cycles, with known model biases especially strong in the North Pacific region. Still, Bhattacharya cautions that limitations remain. Climate models inherently carry biases, and more research is needed to fully decode exactly how human emissions shape the PDO's phases. Gerald Meal at the US National Center for Atmospheric Research sums it up well. The key question, how much of the PDO's behavior comes from natural variability versus human influence, is fundamental and remains open. The reality is likely a blend of both factors. So, what do you think? Are we witnessing a clear fingerprint of humanity on one of the planet's largest ocean cycles? Or is this extended drought just an unlucky turn in natural climate rhythms? Feel free to share your thoughts. This debate is far from settled, and your voice matters in understanding our changing climate.